Everyone, I'm Nathan ZLOMKE. We're going to be looking at this big case text analytics, looking at sentiment analysis of this ISCON location. Located in Bangalore, India, and for the past 3 to 4 years, they've had about 3 employees try to capture and categorize, classify different customer reviews, whether it's from Facebook, Google+, TripAdvisor, as well as these manual paper forms that they have on their location. And so, yeah, it's been a very manually intensive process that they're trying to automate, get more powerful analysis, as well as reduce any bias in classification and, yeah, interpreting what customers are saying. There's also an express need for time analysis and trying to figure out when we do have negative reviews, is there a certain pattern we're seeing across time? And is there any action items we can discern from this? Over the approach, and so I used 4 different types of analysis. One was a timeline analysis, as previously mentioned, using customer ratings over the course of different time variables. SAS data pipeline using text analytics was used as well as a model. Python, this was not a full-scale model, it was actually just the most common words and then making a list from that and a word map. And then Python, I also used a bag of words model called Vader, and then a linguistic, more powerful natural language processing model called Roberta. Before we look at the timeline analysis, I do want to point out this graph on the right. This is just the distribution of the distribution of review ratings according to the different source they came from. And so you see in yellow, TripAdvisor is a predominant one, and then you see Google+ as well, and then Facebook being third. So yeah, I stratified the reviews based off of negative 2.5 or less. Neutral was between 2.5 and 3.5, and positive was 3.5 and up. So this is just the overall timeline average reviews of the overall time from January 2013 all the way to July 2017. And so you see the first couple of years it dips quite a bit, and then it goes into steady state down the road. And so looking at negative reviews, yeah, you don't see too much on the first few years, and then you see a bit more noise in this portion. I think this is just the volume of reviews coming in. You do, when you have more positive, you also have more negative reviews, and so you don't see any negative reflection over here. Regarding positive reviews, I wanted to point out there's this valley, right, or this plateau right here, and then right here, and both of these plateaus, you can't see it as well here, but they stay here and then they kind of jump up to a new level of magnitude, and then they stay within that. And then here as well, it actually dips, plateaus, and then it jumps right up. And so I don't know if there's anything significant going on right here and right here as far as time goes, but yeah, I think some things could be looked into regarding that. Days of the week, you can see in all these reviews we'll look at today, there's a very high skew towards positive reviews, and so that's why on the bottom graph I've pulled out percentage-wise what are the percentage we see of negative and neutral reviews, and you can see this is scaled from 75% to 100%. And regarding negative reviews, you don't see any significant jump. You do see Tuesdays has a bit more negative reviews than any other day in the week, as well as Sundays, with the lowest being on Thursdays. Similar skew with positive reviews. You do see a higher volume in June and July, and so maybe summer months people are traveling, and then you see really low volume in October, November. And then looking down at the bottom graph, again, April is very positive, October very positive month as well, and then negative month most was September. Looking at years, I do want to point out that across time, year over year, you do see a higher volume overall. It's just trending upward regarding, yeah, all reviews. And so looking down at the bottom again, yep, more negative in 2013, 2016, but again, nothing too significant. You do see a lot more neutral reviews on the beginning side of things, and then towards the end it starts getting more more stratified, whether it's positive or negative, and less neutral reviews. So next I want to get into the text analytics from SAS. And so this was a ETL pipeline, loading in the data and then taking it through the different nodes in the pipeline. And this is really convenient and interactive, where the user can further refine different categories and providing active learning for the computer to go off of and reprocessing it. And so we're able to look at things like this word net and find associations regarding your different variables you're trying to look at, and gather intel on what's related to what. So here shops are related to sell, obviously, and so you can explore things in the active learning process better. This graph on the right shows some of the parts of speech tagging that SAS automatically did, and then I went ahead and added 2 classifiers. I added money and emotions because money was, we saw a lot of trend in that, with especially negative sentiment, and then emotions was a need from ISCOM that they wanted to be able to capture emotions, and so I tagged that as well. So you can see those 2 are significant in this group of tags. Into some of what those emotions were from that previous tag is peaceful, love, calm, kind, serenity, relaxed, and so all very positive emotions that it pulled out. Unfortunately, we didn't get a lot of negative emotions that were useful. So anytime people seem to have negative emotions, or negative sentiment, they usually didn't classify it with emotions. They just complained about whatever event occurred, and so negative emotions weren't really something that was able to be pulled out this time in this model. Here's a word net of just the overall main terms that came out that SAS put together. So you see the location, the topic, peaceful, food, things like that. Look at different machine learning models that use what we've looked at already, with different categories that have been defined in the text analytics, to use them as input variables in making predictions, classifying what are the different review ratings. And so this is good to understand how well our model understands our data, how well the categories predict the outcomes. And so we can feed that through the active learning loop. As we further understand the data, we can try to pull out even other categories, and do these perform better in trying to predict customer behavior. You can see on the left, the fit summary has commercialized, not great, unique place, experience, and calm atmosphere as very important input variables in making predictions in this model. You see the misclassification rate in this logistic regression model is about 35.8%. So overall, pretty good accuracy. It's got about 65% correctly predicting rate. And so looking at gradient boosting, you see similar input variables. However, commercialized seems to be way more important than the others. You see a very similar misclassification rate, slightly lower, but very slightly. And then we'll look at neural net. Actually had the highest misclassification rate of all the models, so this was the least accurate, and logistic regression was the most accurate. That machine learning model approach, it actually helps us understand how well the model is able to understand the data it's looking at, how well the categories I placed and defined under are representative of the data as input variables. And then as throughout the active learning cycle and the process of trying to refine this model, you can take different categories and test it, feed it into the model, see if it performs better, and see, are there different emotions that actually perform better than, say, peaceful or something like that, that actually give better insights into what customers are saying and feeling about the product in question. And so going further, looking at this Python processing, this wasn't actually a full-scale model. It was stopped short of actually providing numerical analysis of each keyword, but it did go through the process of stemming the words and tokenizing and reducing them down. And through that, we could get a most common words. And this was used just to get a feel for, yeah, in this case, it's the positive words. So I said I'd show another word map, and so this is the positive word map. You can see the Python compared to the SAS one on the left. And similar words, peaceful, beautiful, calm, and then the Python actually pulls out quite a bit more than the SAS did. You see food, so great food, love, clean, well maintained, and then yeah, spiritual journey, things like that. And so negative words, so this was filtered again by the 2.5 stratification, and then for positive it was filtered from 3.5 and higher. So the 2.5 and lower ratings looks like the commercialization of ISCON made people feel not great. Perhaps they saw it as irreverent. And so on the SAS, you see food as one of the main negatives, and then commercial and shopping. So this was also taken just in a word list. So the top 15 words, whether it was positive or negative, I pulled out and reduced these down. So you can see highlighted beautiful, peaceful, food, well-maintained, spiritual journey, shop, and the grandeur of the place, where all the main positive emotions or word lists that people felt, and then the negative word list again was mostly relating to money: shop, commercial, sell, irreverent, business, money. And then going into the next model, this is the last model we'll look at, is this NLTK library that was used, and the Vader module that was used within that. And this did all the same things: tokenization, POS tagging. This actually went into chunking, so that's grouping different, if it saw that different words were associated with one another, it was able to pull that out, make associations, and then it assigned numerical values. And this was negative, neutral, or positive numerical values, and just, yeah, what percentage of them was positive, what percentage was negative, of whether it's a document or a statement, and trying to gather the sentiment on what that is numerically. You see this compound number is just kind of a gross estimate it did of taking them all into account. And so I won't read this review, but it is actually a negative review, and the bag of words approach classified it as neutral to positive. And so you do see bag of words is not super powerful. It really just has a numerical value for each word it uses and just kind of sums them up. I did want to compare, so this is review rating that was actually classified and rated, and then using the compound that we just looked at, the compound analysis in the Vader model, how well did it actually perform against the known rating. And so overall pretty well. And then, like I said, the 0 category, where it was actually a negative review, in reality the Vader model classified it as positive, and so that was a high degree of error. So we do see it biased more towards being positive and not being able to pull reviews. And yeah, you see that across the board. You don't even see any negative reviews on that far right. So I'll go into this linguistic model. This was a Roberta model from Hugging Face, and it's in the Transformers library. It is using TensorFlow, and it's using pre-weighted training data that was done from a corpus of Twitter sentiment documents that were classified by users, and that it uses that for training data. And it's much more powerful to take into account tone, linguistics, sentence structure, so it can actually pull out things like sarcasm and take into account the grammatical things going on to make more accurate predictions. And so see from this example, the same example as previous. So on the bottom you see the bag of words Vader model classified it as mostly positive, and then the Roberta model actually correctly predicts it as mostly negative, about 49% negative, 36% neutral. And so this is a lot to look at. And so I do want to point out on the bottom left, you see the Vader model and the top right, and you see that it's a lot, more loose associations as it tries to classify the data, whereas the Roberta model you can see is a lot more defined in its shapes, as able to more definitively bring out different insights and classify customer sentiment. And so that's all I'll point out in here. Obviously a lot could be taken from these graphs, but that is not really in the scope of what we're looking at today. To recap, some of the goals of this analysis was to reduce manual effort and automate the process, making it more user-friendly and less manually intensive. And so if money's not a factor, SAS is definitely a great option. It's you can do active learning pretty well in a feed-through loop of constantly trying to upgrade your model and feed in new data as well. If you do want an open source, then Python, the NLP Roberta model that we just looked at, that's once it's built, it's pretty simple, plug and play, and it's free. So that can catch the tone of the reviewer. That was an expressed need. And let's see, SAS did help capture some emotions. They were, again, pretty much all positive. There's a high bias towards positive emotions, as previously mentioned. And then regarding actionable items, the chief complaint most customers had was just the commercialization of ISCON, and so things that can be done to mitigate against this, as far as maybe taking it off the grounds of ISCON or at the front entrance or something like that. And then regarding positive sentiment was, people really enjoyed the food, how well everything was maintained, and how beautiful it is. And so just keeping up with those things or even improving on them will continue to produce positive sentiment along the road.